Hello learners, welcome to this topic on design of sequential circuits, SR latch and flip-flop. At the end of this topic, you will be able to define sequential circuit and their types, explain the storage elements and their types in sequential circuits, describe the design of the SR latch and flip-flop. Sequential circuits are digital circuits, in which the current output depends on the previous input, output and current input. They require storage elements to retain past information. Therefore, sequential circuits consist of two components: combinational circuits and memory elements. Past data is stored in a memory element, and is applied to the input of a combinational circuit with present input to generate present output. In sequential circuits, the memory element is commonly known as a latch or flip-flop. Types of sequential circuits are basically two, that are 1. Synchronous sequential circuits, and 2. Asynchronous sequential circuits. Synchronous circuits change their output based on a clock signal, while asynchronous circuits change their output based on input signals without using a clock. Now, we will see about the different sequential circuits in digital electronics. Latches, flip-flops, registers, counters, state machines. The basic storage element in a sequential circuit is a latch or flip-flop. It has two stable states, either logic 1 or logic 0. Latch or flip-flop can be designed using either NAND gates or NOR gates only. The logic circuit shows an SR latch using NOR gates, where one input to the NOR 1 gate is R and another input is Q bar. Similarly, the NOR 2 gate has one input as S and another as Q. The operation of the NOR SR latch is as follows. From the name of the latch, S represents set and R represents reset. If R is 1, the output will be 0. If S is 1, the output will be 1. To begin with, the SR latch using NOR gates. Let's first assimilate the truth table of the NOR gate. Now let's look at each possible combination. In case 1, when S equals 0, R equals 1. Here, one of the inputs of NOR 1 is 1 and NOR 2 is 0. Referring to the truth table of the NOR gate, if any of the inputs is 1, the output is 0. Therefore, the output of NOR 1, Q, is 0, and the output of NOR 2, Q bar, which is the complement of Q, is 1. Verify the output with the truth table of the NOR gate, because now the two inputs of NOR 2 are S equals 0 and Q equals 0. This is a reset condition. In case 2, S equals 1, R equals 0. One of the input of NOR 1 is 0 and NOR 2 gate is 1, so Q bar equals 0. And this results in Q equals 1 through the cross-couple connection, as the two inputs of NOR 1 is R equals 0 and Q bar equals 0. This is a set condition. In case 3, when S equals R equals 0. When one of the inputs of NOR 1 and NOR 2 gates is 0, then previous states influence the outputs of NOR 1 and NOR 2 and result in a memory state, that is, no change. In case 4, when S equals R equals 1, as one of the inputs of NOR 1 and NOR 2 gates is 1, the outputs Q equals Q bar equals 0, but for the SR latch, the condition is Q bar has to be the complement of Q, which fails when S equals R equals 1. So, this case is undetermined. As the output is stored or latched, this is called a latch. With this, we have come to the end of this topic. Thank you.